All right, in the first part of 2.8, we are going to talk about combining functions. So that's going to look like adding, subtracting, multiplying, and dividing two different functions. So with this notation, right, all this means is I'm taking the function f of x and adding it to the function g of x. All right, that's what this notation means. Same thing for this one. This just means I'm taking f of x minus g of x. This notation means I'm taking f of x times g of x. And then this notation means I'm taking f of x divided by g of x. Right? So this one, we also have to specify that the denominator cannot be 0, and we'll look at that when we talk about domain of these functions here in a minute. So let's jump right into an example. Let's say we're given 2x squared minus 7x plus 3 for f of x, and then 4x plus 1 for g of x. So the first one, I want to find f plus g of x. Well, that just means, oops, f of x plus g of x. So that's going to be 2x squared minus 7x plus 3 plus 4x plus 1. So when I'm adding, all I need to do is combine my like terms. So I've got x's that I can combine. Negative 7x plus 4x would be negative 3x, and 3 plus 1 would be 4. So here is my f plus g of x. Right? All we're doing is adding the functions together. Same thing for subtraction. Right? We said this just means f of x minus g of x. Okay, so here, the only thing we need to make sure of is keeping our signs straight. So it is a good idea to use parentheses when we're plugging these functions in like this. Okay, this way we can see that I'm subtracting everything in this second function. So when I'm combining my like terms, I'm subtracting negative 7x minus 4x to get negative 11x, and 3 minus 1 to get 2. Okay, so this would be my f minus g of x. Now, the question did also say to state the domain. Well, for each of these first two functions, we just have a polynomial. And we talked about in the last, or a couple sections ago, that domain is really only restricted by a few things. If we have zeros in the denominator, or if we have negative values under an even root, and polynomials do not have denominators or even roots, like a square root. So the domain would just be everything, all real numbers, negative infinity to positive infinity. Same thing for b here. All right, so my third example here, f over g, right? Again, we said this just means f of x over g of x. So here, that's going to be 2x squared minus 7x plus 3 over 4x plus 1. All right, so we would want to try to simplify this if we could. So the only way that we could potentially simplify would be to factor the numerator, right? So let me come off to the side here and see if we can factor that. So I want two numbers that multiply to 6, right? A times c would be 6, and add to negative 7. So that could be -1 and -6, right? So I could rewrite this as 2x squared minus x minus 6x plus 3. Group the first two, group the second two, and I could take an x out of here and say this is x times 2x minus 1. And then here I could take a -3 out, and I'd have -3 times 2x minus 1. So this factors into 2x minus 1 times x minus 3. So if I put that back in here, we can see that nothing will cancel. Okay? None of these factors are the same as the denominator, but we still need to check that. All right? Now, to state the domain, we said, well, we can't have the zeros in the denominator. So what we did was we said, well, the denominator cannot equal 0. And then we solve this. So subtract 1 over, divide by 4. We get that x cannot equal -1/4. So the way that we wrote our domain then, we said, well, we can have any value except -1/4. So we said, well, I'm going to start at -infinity and go up to -1/4, not include that with a parenthesis, and then pick back up, not including -1/4, and go up to infinity. Remember, that's how we exclude a single value from the domain using interval notation. Okay, so f divided by g looks like this, and the domain is just skipping this one value. All right, now let's take a look at combining functions and evaluating at a certain point. Okay, so for these, it's probably going to be easiest to evaluate like this. All right, I'm just plugging -1 in for g and plugging -1 in for f. So that's going to look like 2 times -1 squared minus 7 times -1 plus 3 all over 4 times -1 plus 1. So -1 squared is 1, times 2 is 2, -7 times -1 would be +7, plus 3, over -4 plus 1 would be -3. So that's going to be 9/12 over -3, which would reduce to -4. Okay, so all I'm doing is plugging in this value into the function to evaluate. Right? So why don't you guys try the next two? All right, so here we've got f times g of 3. And remember, we said that just means f of 3 times g of 3. So I'm going to evaluate f of 3. So 2 times 3 squared minus 7 times 3 plus 3. And then multiply that by 4 times 3 plus 1. So we get 9 times 2 is 18 minus 21 plus 3 times 13, 12 plus 1. So 18 minus 21 is -3, plus 3 is 0. So we get 0 times 13, which would just be 0. All right. Then for the last example, we have g minus f of -2. So this just means g of -2 minus f of negative 2. So g of negative 2 is going to be 4 times negative 2 plus 1 minus 2 times negative 2 squared minus 7 times negative 2 plus 3. So 4 times negative 2 is negative 8 plus 1 would be negative 7 minus negative 2 squared is 4 times 2 is 8. Negative 7 times negative 2 would be positive 14 plus 3. So we end up with negative 7 minus 22, 25, which would be negative 32. All right. So the next idea is this from a graphical perspective. Okay. So in this picture, I'm given two functions, right? The blue line here is g, and the red line is f. So I want to evaluate these from the graph. So f plus g of 2, well, that just means f of 2 plus g of 2. Right? So we can evaluate that from the graph. If I look at my graph, f of 2 means go to where x is 2 and find the y value. So here's where x is 2. The y value is negative 2. So this will be negative 2 plus g of 2 will be up here at 5. So negative 2 plus 5 gets me 3. From this graph, f plus g of 2 is equal to 3. Right? We can do the same thing for all of these. Okay? F minus g of 4 just means f of 4 minus g of 4. And again, I can get those values from the graph. F of 4, so 2, 3, 4 is right here at 2. Minus g of 4 is right here at 3. So f minus g of 4 is negative 1. Okay, so why don't you guys try the next 3 here? G minus f of 0, f times g of 1, and f divided by g of 2. All right, so this is just g of 0 minus f of 0. G of 0 is 3. F of 0 is 0. So this would end up being 3. F times g of 1 is f of 1 times g of 1. F of 1 is negative 1. G of 1 is up here at 4. So this would be negative 4. And f divided by g of 2 just means f of 2 over g of 2. So f of 2 is negative 2 over g of 2 is 5. So we just get negative 2/5 for that. The last one, we want to do f times g of 5. Okay, so here, f of 5 is 4. So this is f of 5 times g of 5. So f of 5 is 4 times g of 5. Well, there is no value of g of 5, right? G doesn't extend out to x equals 5. So that's undefined. So since we don't have that value, we just say that this whole thing is undefined. All right? The final idea is talking about the domain of combined functions. All right, so given two functions, the domain of f plus g, f minus g, and f times g is just all the values that are common to the domains of both of those functions. In other words, it's the intersection of those domains. So the domain of division, if we have f divided by g, is the same thing, the values that are common to those domains, except we also have to exclude the values where the denominator is 0, which in this case is g. So let's take a look at an example of that. Okay, so let's say we have f of x equals the square root of x plus 2, and g of x equals the square root of 5 minus x. So we want to find the domain of each of those functions. So let's say domain of f, we have a square root. We said that we cannot have negative values in the square root. So what we did was we said, well, whatever's inside of that square root has to be greater than or equal to 0. So to solve this, I would just subtract 2 over, and I would get x has to be greater than or equal to negative 2. That's the domain of this function. And I could write that like this, right? I could say negative 2 to infinity if I want to write that in interval notation. Let's do the same thing for g. The domain of g, again, we want to take this 5 minus x and say that has to be greater than or equal to 0. So I can just add my x over, and I get 5 is greater than or equal to x, or that would be the same as saying x is less than or equal to 5. So in interval notation, if I want all values less than 5, I would say this, right? That's how I would write that in interval notation. So for the domain of f plus g, f minus g, and f times g, what I want is the intersection of these two things. It might be easier to visualize if we put both of these on a number line. Okay, so let's say, why don't I just get some lines here? Okay, so the domain here, we're saying we're going from negative 2 to positive infinity. Here, I'm saying I'm going from negative infinity up to positive 5, and I stop there. The only part that is common to both of those domains is just this section right here, from negative 2 to positive 5, right? That's the intersection. That's the part that's common to both of those domains. So what we can say is the domain of f plus g, f minus g, and f times g is negative 2 to 5, right? Now, if I want f divided by g, I also have to exclude anything where g would be equal to 0, okay? So here, if I'm looking at this function, right, we want to say, well, this cannot equal 0. So it's pretty easy to see in this case that 5 would make this equal to 0, which means we would just have to exclude 5. So we would say the domain of f divided by g is negative 2 to 5, not including 5. Right? We're just excluding that one value. Right? Let's take a look at one last example. Okay, so let's say my f of x is x plus 2 over 3 minus x, and my g of x is 2x plus 13. So I need to find the domain of both of those. So in my f, I have a denominator. Anything that makes the denominator equal to 0 is not part of the domain. So this is what I need to do. I need to say the denominator cannot equal 0. solving, can just add the x over, and I get that x cannot equal 3. So the domain, if we want to write it in interval notation, we would say negative infinity to 3, skip 3 like that, and then 3 to infinity. The domain of G, well, this is just a straight line. There's no denominator, there's no roots. So the domain of G is just everything, negative infinity to positive infinity. So the intersection of these two domains would just be this, okay? So the domain of f plus g f minus g, and f times g is negative infinity to 3, skip 3, and 3 to infinity. Then the only other thing we have to take a look at for f divided by g is where g equals 0. So we want to say, well, 2x plus 13 cannot equal 0. Subtract the 13 over, divide by 2, and we get that x cannot equal negative 13 over 2. This is another value excluded from this part of the domain. Right? So we're saying, in addition to excluding 3, for f divided by g, we also have to exclude negative 13 over 2. So the domain of f over g is negative infinity to negative 13 over 2, skip negative 13 over 2, and then I'm also skipping 3. So I'm going to go up to 3, union that with 3 to infinity. Okay, so that's it for this video. The final question is going to pop up asking you what questions you still have.